Good morning students. In this video we are going to discuss about moment of inertia. In the last video we told about moment of force, it is called torque. Then we told moment of momentum, it is called angular momentum. And third one, moment of linear inertia, that is called moment of inertia. So, moment of inertia is actually the rotational inertia of the body. So, the rotational inertia of body is called moment of inertia. So, we already know what is meant by inertia. It is the inability of the body to change the state of rest or uniform motion. If the body is having more inertia, more difficult to change it, and if the body is having less inertia, we can easily move it. For example, I can easily push and move a cycle, but it is difficult for me to push a car because car is having more inertia. Similarly, if the rotational inertia of a body is more, it is very difficult to rotate the body, and if the body is already rotating, it is very difficult to stop the body also. So, moment of inertia is the rotational inertia of the body. And how will we define the moment of inertia? It is defined as the sum of the products of the masses of the particles constituting the body and the squares of their respective distance from the axis of rotation. I will just give you an example. Imagine like this. This is the axis of rotation, and I take a rigid body of any irregular shape. Rigid body consists of many particles, M1, M2, M3, etc. Mn. There are n particles, and this rigid body is rotating about this axis with a uniform angular velocity omega. I mark anti-clockwise direction. That means the entire rigid body, if suppose this is the axis and this is the rigid body is rotating in the axis like this, in the anti-clockwise direction. That is what the figure means. From the first mass, the distance towards the axis of rotation is marked as R1. This distance is R1. From the second mass, the distance is R2. From the third mass, the distance is R3. Similarly, for the nth mass, the distance is Rn. Then the moment of inertia is denoted by I, which can be given as m1 into r1 square. That is what, by the definition, I showed you the definition, product of mass and the square of the distance. m1 into r1 square plus m2 into r2 square plus m3 into r3 square plus etc. plus mn rn square. This can be written as I is equal to sigma I equal to 1 to n mi ri square. This is the smallest representation of our real equation when I equal to 1 to n. So, when I put I as 1, you will get m1 r1 square. When I put I as 2, m2 r2 square, and then sigma means adding. So, it is a representation of how to write the moment of inertia. Now, let me tell you one thing. Here we have a system like this. Now, you just think like this. How many particles are there? We don't know. We don't know how many particles. There are n system of particles. So how will you calculate using this formula? Formula is easy, but since we don't know the number of particles, this sort of calculation will not work out. So what I do is, I will assume a point where the entire mass of the rigid body is concentrated. That point is called the center of mass. So I am going to assume a point where the entire mass of the body is concentrated. I just mark that point here and I write capital M for total mass, the point where the entire mass is assumed to be concentrated. From that point to the axis of rotation, I mark the distance as k. I mark the distance as k. This k is called radius of gyration. Gyrate means the body is rotating in an axis. That is called gyrate. Radius of gyration. Some persons will say gyration. Both of them are okay. So either radius of gyration or radius of gyration. So mk. So m is the total mass and k is the distance from that mass to the axis of rotation. So this equation can be written as I is equal to m into k square. This is the easier expression for the moment of inertia. So if I know radius of gyration, then I can find the moment of inertia using I is equal to mk square. Okay. Now, what is the SI unit? SI unit of moment of inertia? Mass. Mass is kilogram. K is radius of gyration, which is radius. So kilogram meter square. That is SI unit of moment of inertia. Now from here, I is equal to mk square. What is k square? K square is equal to I by m. Right? K square is equal to I by m. So k can be written as root of I by m. So if in an exam, if they have given I and ask you to find radius of gyration, then k is equal to root of I by m. Yes, please note down. Okay. Now, what are the factors affecting moment of inertia? The first factor, moment of inertia depends on the first factor, mass of the body. Obviously, if mass increases, moment of inertia increases. The second factor, the shape and size. For a uniform body, the center of mass is at the center. But for a non-uniform body, center of mass will be somewhere closer to the region where more mass is there. So depending upon that, moment of inertia will change. That is what shape and size. Then distribution of mass about the axis of rotation, where the axis is kept. For example, I want to rotate this pen. If I keep this as the axis, the pen will rotate like this. It is having one moment of inertia. Now, if I keep this as the axis, the pen will rotate like this. It is having another moment of inertia. Now I can fix axis here, then the pen rotate like this. I fix the axis at this end, then the pen is rotating like this about that axis, which is having another moment of inertia. So moment of inertia changes when the axis changes, the position and orientation of the axis, the distribution of mass about that axis. So these are the four factors. Now, what is meant by radius of gyration? We have already discussed when I was drawing that figure. Radius of gyration is defined as the distance from the axis of a mass point whose mass is equal to the mass of whole body and whose moment of inertia is equal to the moment of inertia about the axis. That means you assume the whole mass of the body is concentrated there and whose moment of inertia will be the moment of inertia of the entire rigid body. That is what I meant. So I is equal to, this is the definition, so I is equal to m into k square, where k is the radius of gyration, and SI unit of radius of gyration is radius, no, so it is meter only. Now I already told moment of inertia is different for different bodies. I am just displaying a figure which gives you the idea about the moment of inertia in different axes and for different mass distribution. Those are the 4 factors we told, no? It depends upon the shape and size, depend upon the mass, depend upon the distribution of mass about the axis of rotation, and position and orientation. So when the axis changes, what about the moment of inertia? When the distribution of mass changes, what about the moment of inertia? Those all things we are going to see now. Listen, the first one, a thin circular ring of radius r. Thin circular ring of radius r. I am making the axis here perpendicular. Axis is perpendicular to the ring, and the equation for the moment of inertia is mr square, where m is the mass and r is the radius from the axis of rotation. Now see the second one. See the second one. Circular disk of radius r, perpendicular to the disk at the center. So first one was the ring, second one is the disk. The axis is same, but think about moment of inertia, it is half mr square, half of that at the first one. Okay, so the body is changing, moment of inertia changes. Now you see thin rod perpendicular to the rod at the center. Rod is having a length L and the axis is perpendicular to the rod at the center. The answer is 1 by 12 ml square. 1 by 12 ml square. Now solid sphere, the axis is through the diameter of the sphere. Through the diameter of the sphere. 2 by 5 mr square. You have to learn all these things by heart. In the exam, we will be giving questions like this. For a thin rod, if the axis is perpendicular to the rod at the center, what is the moment of inertia? And you will be giving 4 options. You have to select that. Similarly, for a solid sphere whose axis of rotation is about the diameter, what is the moment of inertia? 2 by 5 mr square. So like that you have to learn, you have to memorize it. Okay. For a hollow cylinder, to the axis of the cylinder, what is the answer? mr square. So please compare hollow cylinder and ring, moment of inertia is same, because you take a hollow cylinder, cut a small portion, you will get a ring. That is why both of them are having same moment of inertia. Now instead of hollow cylinder, if I am taking a solid cylinder, look here, if I am taking a solid cylinder, then the answer is half mr square. Now solid cylinder, half mr square. Now you see this circular disc, half mr square. That means circular disc and solid cylinder is having same moment of inertia. You take a solid cylinder, cut one slice, you will get circular disc only. Okay, now one more thing, here it is a solid sphere, no? For solid sphere about the diameter, I have marked 2 by 5 mr square. Instead of solid sphere, if it was hollow sphere, the axis is about the diameter itself. Hollow sphere axis is about the diameter itself, then the moment of inertia is 2 by 3 mr square. This also you have to write. Solid sphere 2 by 5 mr square, and for hollow sphere it is 2 by 3 mr square. Now think, a thin circular ring. Now I am changing the axis. In the previous case, circular ring, the axis is perpendicular to the ring and the answer is mr square. Now you see here, I am taking thin circular ring, but the axis is changing. The axis is like this, passing through the diameter. Then the moment of inertia value will be half mr square. Now, for a circular disc, axis is about the diameter. For the disc again I am changing the axis. So it was 1 by 4 mr square. Think about the previous case. Circular disc, the axis, when the axis was perpendicular, it is half mr square. But now it is 1 by 4 mr square. Similarly, for a thin rod, earlier I was taking the axis through the center and I got the answer as 1 by 12 ml square. See, the axis is through the center of the rod. So 1 by 12 mr square. Now I change the axis. The thin rod perpendicular, the axis is perpendicular. Then it is 1 by 3 ml square. Axis is changing, then the moment of inertia value also changes. Now, for a plate, for a thin plate, length is L and width is W. Length is L and width is W. So 1 by 12 m into L square plus W square. Length plus width, or you can say length plus breadth. So m L half, not half, 1 by 12 m into L square plus W square, or L square plus B square. That's what you have to take. So that's all about moment of inertia. Thank you.